All right, so last time we just present. It didn't stop on a string. I did explain how to drive this equation for harmonic when we have a close end or when we have a string here. We did this worksheet, right? We did go through the harmonics. When you have a string, there is close end, two notes happening at the ends, and so on. We did some questions. Now, so this is what we worked last time, right? I'm gonna continue with open end air column. So let's just fill in the blanks here first. So standing wave pattern consists of the nodes and antinodes. Position along the medium that appear to be stationary. What do we call that? Can anyone tell me? The stationary position, is that node or antinode?
Is it no?
It is node, right? The one that is not moving. And if I want to do it for open air column, one end open, is that one end open? No, it's both end opens. We will actually, they're talking about the nodes later on. And the one that is going from maximum position to the minimum position, we call it antinode. They are the opposite of the points of notice. Okay. Each consecutive nodes separated from each other by how many lambda? So this is my full wavelength, right? That would be node. This one is node. And here the maximum or minimum is antinode. Each consecutive nodes, so the first node here, the second node is here. Each consecutive node is separated by how many lambda? If this is a full lambda, what would be the separation between two nodes from here to here? Can anyone tell me? How many lambda is from node to node? Is a quarter of lambda, is a half lambda, or is a full lambda?
Is it full?
It is half of that, right? So if from here to here is full lambda, so that would be my half. So it's going to be half of the lambda. Thank you. Now, an open end air column. Open end air column means both ends is open. Usually enclosed within a tube, a pipe, or other narrow cylinder that's capable of being forced into vibration resonance. Both ends of the column are open to the surrounding air. Air at the end of the column able to vibrate back and forth. So the wave vibrate back and forth here. Therefore, it's forming antinodes there. Now, if I want to draw the first harmonic, this should be maximum, minimum here. So I need to form a node here, and that would be the shape of my first harmonic. This is the shape of the first harmonic. And how the length is equal to how many lambda? Can you guess how many lambda is this shape?
Is it one?
So this is the full lambda. I'm gonna just put the picture for you for the full lambda. Here to here, right? Is a full lambda. Maybe I just continue that. This is two lambda, right? So The distance between the maximum to maximum, right? I know it's gonna be one lambda, but don't be confused here. Don't make that confuse you. If you look at this is maximum, and if you continue to minimum, right? So that would be then how many lambda if you just go there and see from the maximum to the minimum. It's like from here to here. Wait, I just changed my color. Just look at one of that. So it's from here to here. One maximum to minimum. How many lambda is there?
Half.
Half of the lambda, right? Thank you. Now, or you could say that this is a quarter and this is another quarter. We have a 2/4 because it's from the maximum to the node is 1/4, and here another 1/4. The total is going to be 1.5. Now, the second note, it would be when you have the second harmonic, when you have two notes here. Again, you need to have a maximum or minimum at the open end. Now, can you tell me how many lambda is fitting here? Again, this would be from minimum to minimum, right? Same point. Means how many lambda? If the full length wavelength is here, it's kind of from minimum to minimum, true? How many lambda is fitting there? It's gonna be full lambda or 2/2. Again, how many quarters do we have here? 1, 2, 3, 4. 4/4, 4/4 or 1. So for the third one, I need to have 3 nodes here. 1, so can anyone tell me how many wavelength is fitting here? Anyone? So looking at this, from maximum to maximum is the one wavelength. And from the maximum to minimum, it is half a wavelength. So 1.5. 1.5 wavelength is like 3/2. Is that clear? Now, next one, 1, 2, 3, 4. I need to have 4 of that here. And this is what I do. Try my best to draw it nicely. And how many wavelength do you see here? Again, from maximum to maximum is one full wavelength. And from maximum to maximum, another full wavelength, right? There's gonna be 2 full wavelength. Or I can say that this is 4/2. 4/2 is 2. I'm gonna just draw the rest. One, two, three, four. Next one I need to have 5. 1, 2, 3, 4, 5. Okay. How many wavelength? Again, from maximum to maximum is one. Maximum. Oh, what is it? Yeah. From this maximum to the maximum here, one. From maximum to maximum, two. 2.5 is going to be 5 over 2. So for the lambda, I can just invert that. So it's going to be 2 to the other side. It's going to be 2. Here, again, going to be 2 over 2 over 1. It's 2 over 3. Here is 2 over 4. And here is 2 over 5. Now, if I want to formulate this, see all of that denominator is 2. That would be L is equal to lambda. Now, I need to figure out this. For first harmonic, we have 1. Second harmonic, we have 2 in numerator. Third harmonic, we have 3 in numerator. Fourth harmonic, we have 4 in numerator. And so on, right? So I can say that this is n over 2. And n is the number of the harmonic. And then n is starting at 1, 2, 3, and so on, okay? Got it? Now, third harmonic for an error column whose first harmonic is 384 hertz. So I can drive that equation for you, knowing that L is equal to n over 2 multiplied by the lambda, right? And we know that from the universal wave equation, we know velocity of the wave is frequency multiplied by lambda. So this is the lambda n. Here is, I know the length is constant, but here is n and here is lambda n. Just put this little subscript. If it is the first harmonic, it would be the lambda belong to the first harmonic. Also, I just put a little n here, little n here, make sure that they are for the first, could be for first harmonic, second harmonic, and so on. And instead of the lambda, I'm going to rearrange for lambda n. So lambda n is equal to 2L over n. And instead of the lambda n, I will substitute. I will substitute 2L over n, right? And then for the, I'm gonna just solve for f of n. F of n is equal to velocity multiplied by n divided by 2L, okay? Knowing that f of 1 is gonna be v multiplied by 1 divided by 2L. Now knowing that f of n is vn over 2L, this would be my first harmonic, right? Now, f of n is going to be first harmonic multiplied by n. Like the third harmonic, if the first harmonic is 383. If the first harmonic is 383, 84. The third harmonic is that. I want to find the third one, means the n is 3. And I will get my answer, right? And I just need a calculator to do that. Okay. I want to ask everyone to take some time to do number 8 for me. You have this wave, the length of that 63 centimeter that is tube. You want to find the wavelength. I'm going to give you 2 minutes to think about this question. Okay. If you have your answer, can you turn on your mic and tell me what did you get? Anyone? So you need to use this equation. L is equal to n over 2 lambda. You need to tell me which harmonic is that first. How many lambda do you see fitted in this picture? Anyone tell me? How many wavelength do you see here? Like from here to here is a quarter. Is 1 over 4. Let's see how many quarter do we have. Is another quarter here. Another quarter here.
One lambda.
Okay, that's good. Yeah. I have 1, 2, 3, 4, 5, 6. 6 quarter actually. Oh.
3/2.
So what?
So each of that is a quarter from maximum to
So it's
this.
1/2.
From here to here is 1 over 4. Again, from here to here is 1 over 4. 1 over 4 here, 1 over 4, 1 over 4, 1 over 4. I have
Yeah, I'm
6
aware.
of them, right? I have
It's
6 over
one.
4, which is 3 over 2. So that would be lambda is going to be 3 over 2 lambda, right? We have L, which is 0.63 meter. Just the lambda going to be 0.63 multiplied by 3 over 2. If you do that, multiply by 3 over 2, it would be what? Actually, reverse. Multiply by 2 divided by 3. Let me just do that. 0.63 multiplied by 2 divided by 3 is 0.42. Everyone got it? So you really need to understand. Any question, anyone? About how many wavelength fitting here? Steven, we're talking about the full wavelength. There is 4 quarter here. From here to here is 1/4. From here to here is 1/4. From here to here is 1/4. There is 1/4. When you add them up, 1, 2, 3, 4, it's gonna be 4 over 4, gonna be 1 lambda, right? So full lambda. The same thing here, you can count it quarter by quarter. Let's say I got 6 of them, it's gonna be 6 over 4, just simplify that 3 over 2, okay? Hope got it. I'm gonna give you a minute for this one. Stan is playing his open pipe and pipe. The frequency is given to you. The speed of sound through the pipe is given. Find the frequency of the first harmonic and the length of the pipe. Question number 7, I'm going to give you 3 minutes to work on that. And if you have your answer, please let me know. Okay, anyone got the answer here? Do you need more time? If you need more time, please let me know in the chat.
Can you explain how to do it?
Okay, sure. So, explain open end pipe. You need to know the open end pipe. The equation is L is equal to N over 2 lambda. Okay, this is one thing. Also, you need to know the universal wave equation is V is equal to frequency multiplied by lambda. Okay, so the frequency of the second harmonic we have F2 is 882 hertz. The speed of sound V is 345 meter per second. And I'm asked to find the frequency of what? The frequency of the first harmonic. And I'm asked to find the length of the pipe. So frequency of the first harmonic is easy because I know the f of n is going to be n f1. If I have f2, maybe I just use that here. I'm going to do this here. F of n is equal to n f1. If I know f of 2, which is 882, I can find f1 just by dividing that, right? It's 441 hertz. Now, another question asking for L. So L is here. Okay, so L is here. I can find the frequency for second harmonic, right? I can find the lambda for the second harmonic. Just oh sorry, we do not have L, right? We have okay, I can substitute that there. And instead of the lambda, I can put what? 2L over 2L over N. I'm gonna just substitute it here. Velocity is equal to frequency. Instead of the lambda, we put 2L over N. Then the length gonna be what? V multiplied by N over 2 frequency. Since I know the second harmonic, instead of the N, I could put 2 and frequency of harmonics, and I have velocity. Velocity is 345. My N for second harmonic, because I want to find the frequency of the second, put the frequency of the second harmonic, which is 882. Or I could do the frequency of first harmonic with 1 over 441. Doesn't matter, right? And if I do that, 345 multiplied by 2 divided by 2 divided by 882 is 0.39 meter. Okay? So that was my first one. That was kind of my second one, third step. Any question? Okay, I'm gonna post these notes if you want to write it down. Just go get it. The solutions. Okay. We want to do closed end air column. The one that is one end closed. Again, we do the same process. We derive equation and we do a couple of questions. Now, a standing wave pattern consists of node and antinode. The position along the medium that appears to be a stationary, again, that would be node, the one that is not moving. And the one that the displacement is positive, negative, that would be antinode. They are the opposite of the point of the node. Each consecutive node separated by what? Again, two consecutive nodes. This is node and this is another node. They are separated by half of the lambda. I did explain that before. And the air at the open end of the column able to vibrate back and forth. This end forming what? Antinode, because it's free to vibrate. And the one that is not allowed, the one that is not allowed to vibrate is closed end. We call it node. Okay? This is node, this is node. Now, let's just do this. At the end that is not vibrating is going to be node, and at the end that is vibrating is going to be maximum. So the simple form of that is when I just do this, so to form a maximum and minimum at the end. So can anyone tell me how many lambda is fitting in the first harmonic? How many lambda is fitted here? Again, that would be my full length, full lambda. I can divide it by 2 to 4 quarters. 1 over 4 here, 1 over 4 here. So it means from node to the maximum is a quarter, right? It's going to be 1 over 4. For a third harmonic, I need to have a note here. Okay. Now, how many wavelength again? I just divided to the quarter. 1, 2, 3. It's 3 quarter. 3 over 4. For next one, I will put 2 notes middle. Can anyone tell me how many quarters do you see here?
5/4.
Very good. 1, 2, 3, 4, 5. 5 over 4. Thank you. Next one, I put the 3 notes here. 1, 2, 3. And now, can anyone tell me how many?
7/4.
Very good. Thank you. Who's this speaking?
Jessica.
Jessica, thank you. So 7 over 4. And the next one, I need to put 4 here. 1, 2, 3, 4. And how many here?
9/4.
Very good. Gonna be 9 quarters. I know it's not that symmetric, but if you just divide it to the 4 quarters, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 over 4. And I can, to rearrange for lambda, I can flip this one. It's 4 over 1, 4 over 3, 4 over 5, 4 over 7, and here is 4 over 9. Now I need to find the generalized equation of that. So L is equal to what lambda? I know the denominator is 4 for all of these relations. And in numerator, what do I have? 1, 3, 5, 7, 9, right?
It's
The
all
num
odd numbers.
Very good, odd numbers. Sometimes we call the odd numbers as 2n minus 1. You can say n is equal to 1, 2, 3, and so on. And make sure the n here not going to be number of the harmonics. Number of the harmonics is your numerator, which is 1, 3, 5, 7. This is kind of number of the resonance. The first resonance, second resonance, third resonance, right? But the number of harmonics is going to be here. And we will do this in equation and you will see that better. Here, third harmonic for an air column whose first harmonic is 262. See, this is the first harmonic, right? And this is the third harmonic. It's kind of the second things, right? So you need to know that from first to third, you multiply it by 3. Okay? So again, the same thing. I will say that f of n is equal to n f1, but here it's going to be number of harmonic, okay? Maybe I just, because I put the n to be like that, 2n minus 1, f1. Third harmonic means f of 3, and the f here is 2, right? The second resonance. Second resonance, I'm going to just put the 2n minus 1. F of 3 is when it's going to be 3f1. Okay, so if I want to do that, f of 3 is going to be just 3 multiplied by the first harmonic, 262. And I do this. I want you to think about 6a, giving you 2 minutes to work on it, and you let me know the answer. Okay, anyone want to tell me the answer? Anyone? Should I do that myself? So can anyone tell me a length is equal to how many lambda here? How many lambda is fitting here?
Is it 5/4?
Yes, 1, 2, 3, 4, 5. 5/4, right? Good. And the lambda would be 4/5 length. Length is 0.35 meter. 0.35 multiplied by 4 divided by 5. 0.28. Okay. Now I want to give you 2 minutes for 3 minutes for number 7.
Wait, Miss, can you go back up for a minute?
Sure.
Okay, thank you.
Yes. Number 7, 2 minutes. Okay, can anyone tell me the answer? Anyone? Okay, I just should do that myself. Okay, here is a test tubes have a gig in the local park this weekend. The lead instrumental used the test tube closed and air column with 17.2 centimeter air column. The speed of sound in the test tube is given on the frequency and the first harmonic played by this instrument. So it's going to be one end closed, right? So the length is given to you. The speed of the sound is 340 meter per second. I want to find F1. Not knowing the general equation for first harmonic, I have L is equal to 1 over 4 lambda. And we know that V is equal to what? F lambda. If I want to find F1, I need to find the wavelength for the first harmonic, right? So if this is that, the lambda is going to be 4 is equal to 4L. So sub that there. Going to be 4L. If I'm looking for frequency, it's going to be V over 4L. Velocity, I have 340. L is, I need to convert to the meter, 0.172. And I need a calculator to do this. 340 divided by 4 divided by 172. It gives me 494.18 hertz. Got it? Let me just share this. So basically, I did talk to you about the open end column one and close one and open air column. This is another question. We could do that together. Example 3, example 4. So the speed of the wave on a string with a fixed end and a free end is 300 meter per second. So the velocity is given 350 meter per second. The frequency of the wave is 200 hertz. What is the length of the string necessary to produce the standing wave with a first harmonic? Okay, since one end is closed, one end is open, you know for the first harmonic, you just need to really draw that. The length is going to be 1/4 of lambda. Okay, again, I'm looking for the length. And I know the velocity is going to be frequency multiplied by lambda. Here, if you rearrange for lambda, you get velocity over frequency. And here is 1 over 4. Lambda is velocity over frequency. You just put the number. Velocity is 350 meter per second. And here is 200. And that would give me the length. So the length gonna be 0.44 meter, or if you want to convert to centimeter, it's gonna be 44 centimeter. Any question? I'm gonna do another one. The sixth harmonic of guitar. So this is a guitar. The speed of the sound is given. What is the frequency of a standing wave? So knowing that when you have it closed, so if you have a sixth harmonic, means you have a six notes here. For the first harmonic, let me just do that. For the first harmonic is something like that, okay? For the second harmonic, you have one note here. For the third harmonic, you have two in between. So for a sixth harmonic, you have five. One, two, three, four, five. Okay, so I need to erase the rest here, maybe. Just draw. Okay, one, two, three, four, five, right? Six. And if you want to see how many wavelengths is going to be there, it's going to be one, two, three. Length is going to be 3 lambda for the fixed end. Now, also, you know, frequency, length is going to, velocity is going to be frequency multiplied by lambda. Now, we're looking for frequency. So frequency is velocity over lambda. And here I know the lambda gonna be L over 3. So if you put L over 3 here, is gonna be 3V over L. V is given 206 meter per second and L is 0.65 meter. You need to convert this one to the meter. Need the calculator, 206 divided by 0.65. It gives you 950 hertz. You can round it to 951 hertz. Okay, any question?